Okay, you guys, this section is called partial fractions. The goal is to reverse the addition of rational expressions. So as a review problem, this first example is a review of a problem that you would see in beginning or intermediate algebra. And we're going to go in the forward direction of adding fractions together. This is not what we're doing today. Our goal for today is to undo the addition of rational expressions, but I need to remind you what it looks like to add rational expressions first to give you kind of a place to start. So let's go ahead and add -1 over the quantity x plus 4 plus 3 over the quantity x plus 8. What do we need to add fractions together? A common denominator. Let's put the LCD over here. What's the LCD? Yeah, when they don't have any factors in common, you just multiply them. When the two denominators don't have any factors in common, you just multiply them to find the least common denominator, don't you? And so we're going to take the -1 over x plus 4 and multiply numerator and denominator by the quantity it's missing from the LCD. So we have an x plus 4. Oh, that should have been x plus 8. Excuse me. Did I say x plus 8 and write x plus 4? I don't know what I did. But anyway, it should have been x plus 4 times x plus 8. So this first guy has an x plus 4. It's missing the x plus 8, isn't it? So what do? Multiply numerator denominator of -1 over x plus 4 by the factor that it's missing. Remember that? There's an implied set of parentheses around the x plus 4. Put those in, and we have x plus 8. Make sense? And then on the 3 over x plus 8, what factor is this guy missing? It's missing an x plus 4, so we multiply numerator and denominator by x plus 4, the factor that it's missing. So we're just getting it. What are we really multiplying by in both cases? 1, right? Yeah. So what do I need to do up top in the numerator here? I kind of need to distribute the -1, right? So it becomes -x minus 8. And all of this is going to be in one big numerator now. So let's go ahead. Remember, there's an applied set of parentheses basically everywhere, numerators and denominators. Let's go ahead and distribute this 3. So we're distributing a plus 3. What does that give us? Plus 3x plus 12. And then let's put it all over that common denominator right now. Because remember what we do. We combine the numerators and keep that common denominator. Does that look familiar to you? So what do we get for our answer when we combine like terms? So 2x, so we get 2x plus 4 on top over that LCD, x plus 4 times x plus 8. I could factor out the 2 up top, but I don't think it does any good. You won't end up with a factor of x plus 4 on top or a factor of x plus 8, so you won't end up with any simplification, dividing out like factors, in other words, so I'm just going to leave it like that. Okay, now imagine going backwards, from the bottom to the top. That's what we're doing today. Okay, so in this example, we're going to find the partial fraction decomposition. That's a kind of a mouthful, so we'll say PFD. Partial fraction decomposition of, okay, there's many, and I'll make a summary of this later on, so don't try and write down everything I do. Just write down the, what's important to this particular problem. But we want to look at several situations. In this first situation, we're going to look at a denominator that has non-repeated linear factors, okay? In other words, you won't have an exponent of 2 or 3 or 4 on any of the factors. So, okay, here we go. We have 2x plus 4 over x squared plus 12x plus 32. The very first step is to factor the denominator. Remember what we're trying to do. We want to undo this single rational expression into the sum or difference of other rational expressions where the denominators are in simpler form. So, okay, let's factor the denominator. That's going to be the first step every time. So 2x plus 4 stays the same. Factor the denominator. Help me out with that. X plus 4 and x plus 8. By the way, what do you notice about this? This is, I mean, we know the answer, right? But let's pretend like we don't. We're going to go backwards. Let's pretend like we don't. The answer is the statement of the last problem, but let's pretend like we don't know that. So we're kind of starting from scratch here. Okay, so now what we're going to do is we're going to set up the decomposition. And the problem is we don't know what the numerators are. I mean, we do, but we're pretending like we don't. So we set up the decomposition because in general, we won't know what the numerators are. We have two factors in the denominator. We're going to, and none of them are repeated. In other words, you don't see an exponent of like 2 on the x plus 8. So that's what I mean by non-repeated. The exponent on x plus 4 is 1. The exponent on the quantity x plus 8 is 1, non-repeated. So you have two factors in the denominator, and you're going to expect then two terms in the decomposition. One with a denominator of x plus 4, the other with a denominator of x plus 8. So x plus 4, x plus 8. Now, the problem is, another problem among many, you don't know what the numerators are. So they're going to be constant. How do I know that? Well, it turns out, I can't prove it to you guys at this level, but this is intuitively, I think you'll believe it. This is a proper fraction, right? And what do I mean by proper fraction when I'm talking about a rational algebraic fraction? I mean the degree of the numerator is less than the degree of the denominator. So that's what I call a proper fraction. Turns out when you have a proper fraction, a proper rational expression, then when you decompose it like this, the terms in the decomposition on the right-hand side will also be proper, which means the degrees of the numerators up here and here should be less than the degrees of the denominator. But the degrees of the denominators are both 1, right? So we must have constants here and here. So let's give them a name, A and B. So the degree of the numerator will be 1 less than the degree of the denominator when the denominators are non-repeated linear factors. So then the next step is going to be to clear the fractions. So in the next step, I guess if you want some steps, I could write them down for you. Step 1 is going to be to set up the decomposition. And I'll put it in parentheses, factor the given denominator first, if necessary, right? It's always if necessary. Okay, step 2 is going to be to clear the denominator. So you've created an equation, you're going to clear the denominators. We'll just call them DENs. And you guys think back to solving rational equations. You know how to clear denominators. What do? So you're going to take this equation and multiply through by what to get rid of those denominators? You're going to multiply through by the LCD, aren't you? So the LCD is x plus 4 times x plus 8. And when you do that, the LCD is going to, on the left side, there's only one term to multiply it by, and it's going to end up in the numerator, and it's going to cancel with both the terms in the denominator. So you're just going to end up with the numerator on the left side. And so you get 2x plus 4 on the left side. But on the right side, if you think about it, the x plus 4 times x plus 8 has to distribute to both numerators. And you're only going to have one cancellation each. So what's going to be left? In the first term, a is left. That was there in the numerator to begin with. The x plus 4 will cancel. What factor is left over? When the x plus 8. So do you guys see where that comes from without showing all the work on that? So think of it, maybe it'll be easier if I write it on this side too. So what we're doing is we're distributing this guy. That's supposed to be an 8. We're distributing this guy, and it lands, when you distribute it, it lands in the numerators. So of course, when it lands in the numerator here, x plus 4 cancels with x plus 4, and you're left with a times x plus 8. Does that make sense? plus b times what's going to be left when the smoke settles there? The x plus 8's cancel, and you'll be left with x plus 4. Okay, any questions so far on how I cleared those denominators? It's exactly the same thing you would do if you were solving a rational equation. Okay, clear the denominators. And now we have on the left-hand side, we have a polynomial, 2x plus 4. And on the right-hand side, we have apparently an equivalent polynomial, a times the quantity x plus 8 plus b times the quantity x plus 4. So the technique then, remember what we're trying to do. Essentially, we're trying to find out what a and b are, right? So, so that we can basically fill in this decomposition that we came up with right here. So I'm going to show you the hard way to do it, which works every time, and then I'll show you a shortcut that works really nicely when you have non-repeated linear factors. So the way to do it then, the long way, you're going to distribute the a, you're going to distribute the b, and you're going to collect like terms, group them together. Okay, so let me see if I can write that as a step 3. So this is referring to the right-hand side, RHS. On the right-hand side, multiply out. And group like terms together. Whoops, I went down just a wee bit too far. Okay, so on the left-hand side stays the same, 2x plus 4. Right-hand side, what do I get when I distribute the a and the b? Let's see, I'll get you started. ax plus 8a, and what else? Plus bx plus 4b. And then we group like terms together. That means ax plus bx. And then the constant terms are plus 8a and plus 4b. So plus 8a and plus 4b. And we still have 2x plus 4 on the left side. In step 4, you're going to factor powers of x and set corresponding coefficients equal. I'll show you exactly what I mean by that in just a second. Corresponding coefficients equal. Okay, so back to green here. Left-hand side doesn't change. 2x plus 4. Right-hand side, okay, ax plus bx. Let's factor out the x.
X times quantity a plus b.
Right, but I'm going to write it as a plus b times the quantity, or the quantity a plus b times x, because a plus b is then we can think of that as the coefficient of x. Okay. Yeah, exactly. And then there's not much to do with the constant term, although you could group them together with a pair of parentheses. Right? And then, well, no, you just wanted to factor out powers of x. So here's the idea, guys. If two polynomials are equal, then their corresponding coefficients are equal. So take a look at this. A plus b then must equal 2. That's what I mean by setting corresponding coefficients equal. The constant coefficient is 8a plus 4b, so you wouldn't want to factor out a 4. But you could set it equal to, it just happens to be 4 on the left side. And that gives you a system of equations. So step 5 would be solve the resulting system of equations. So the resulting system is, when you set corresponding coefficients equal, is a plus b equals 2, and 8a plus 4b is equal to 4. Does everybody see what I did there? Is that okay? Any questions? So then let me go ahead and write down step 5. Step 5 would be solve the resulting system and then write the decomposition. How do you want to solve it? Which method do you want to use? Yeah, you guys get so used to elimination that you kind of want to use it. I mean, it wouldn't be bad using substitution either, but elimination's not bad. What could you multiply the top by? Well, -8. And then that gives, well, yeah, either one would work. If I multiply by negative 8 to eliminate the a's, what do I get? So I get negative 8a minus 8b equals negative 16. Add them up. So by the way, I'm not using matrices here, right? This is so quick, you might as well just do it by hand. And so what do I get? Negative 4b is equal to negative 12, or b equals 3. Well, if b equals 3 and you plug it back in up here, what does a have to equal?
Negative 1.
Negative 1. So plug it back in, a plus 3 is equal to 2, and a equals then negative 1. But you're not going to write your answer as an ordered pair. You're using this for something. You're going to fill in the decomposition. So the decomposition then, remember, way up here, it was a over x plus 4 plus b over x plus 8. A over x plus 4 plus b over x plus 8. This is what we're filling in. So what does it become then? You know what a is, you know what b is. You get negative 1 over x plus 4, that's a, plus 3 over x plus 8, which is hopefully what we started with, right? Way up here. Yeah, and it is. I wrote it in a different order, but that's it. So what we're saying then is that original statement of the problem, 2x plus 4 divided by x squared plus 12x plus 32, that is equal to this. Why is that important? Well, you'll see when you get to Calc 2. It's going to help you integrate rational functions. If you don't know what that means, don't worry about it. You're not supposed to. But that's what it's used for. Now, think about, you guys should feel bad for me being a math teacher. We should have a day of appreciation for math teachers. You guys are going to use this stuff when you get to Calc 2. Almost everybody in here is going to Calc 2. But I have to teach this stuff to students taking college algebra. A lot of them don't have to take calculus. And when they ask me, what are you going to use this for? I say, well, this is mathematical appreciation, right? Because you're not going to use it. This is like when you take an art class. What are you going to use that for? It's art appreciation. You're probably not going to use it very much unless you play Jeopardy. So where's the shortcut at? It's pretty cool. You guys are going to like it. Okay. Before you set corresponding coefficients equal, let x equal negative 8. Okay? Now, that means you have to put x in the left-hand side as well. So what does the left-hand side become? If you put in a negative 8 there, it becomes, what, negative 16 plus 4? So negative 12 on the left side equals, well, 0, right? This whole term goes away. That's the whole point. And then plus b times,
X plus 4.
well, no, you're plugging in negative 8, so negative 4. Negative 8 plus 4. So you're plugging in a negative 8 everywhere. That guy, the a term zeroes out. And the b term becomes b times negative 4, right? Yeah. And so if you solve, what's b equal to? 3. Pretty cool, huh? And then let x equal, what's the other thing we could let x equal?
Negative 4.
Well, technically, you could let x equal anything you want, and it will work. But it would be nice to zero this out. Okay, so negative 4. But that trick of letting x be anything you want might come in handy at some point. So if you let x equal negative 4, then what happens? So you're sticking negative 4 in there, there, and there. What do we get on the left side? Now I see what you're saying. Okay, and then when you plug in negative 4 here, what do you get? A times 4, and then zero's out there. So what's a have to equal?
Negative 1.
And isn't that exactly what we got? A equals negative 1, and b equals 3. Part B, we have negative 2x minus 7 divided by x squared plus 4x plus 4. You have to realize the setup of the decomposition differs if you have like repeated factors. In particular, in this example, we're looking at repeated linear factors when you factor the denominator. So let's factor the denominator. We get the numerator is the same. Let me use a different color. Let me use green. Let's keep the numerator and factor the denominator. What does x squared plus 4x plus 4 factor to be?
X plus 2 squared.
X plus 2 quantity squared. Okay. Now again, the decomposition is what we're looking for. We want to we want to decompose this so that it's the sum of rational expressions. But here's something that's a little bit weird. You haven't seen this before necessarily. It's completely possible that when you decompose this, you'll get a denominator of x plus 2 to the first power. Do you guys see why? Yeah, because obviously you have to have a denominator of x plus 2 squared in one of your denominators in the decomposition, right? For the LCD to be that denominator on the left side. Remember, the denominator on the left side is always going to be your LCD. But it's completely possible that one of your denominators in the decomposition in one of the terms on the right side is x plus 2 to the first power. And that's because, think about going the other way where you're just adding the right side to get the left side. When you find the LCD, what's the LCD between x plus 2 and x plus 2 quantity squared? It's the one to the higher power, x plus 2 quantity squared, isn't it? So when going in the usual direction and you're adding the fractions together, that denominator of x plus 2 to the first power disappears completely when you're adding in the usual direction. But when you're decomposing, you have to take into account that it could be there. And so that's the setup, you guys. Now, one thing I'll point out for homework purposes is this. I'm only going to change it temporarily, so you don't want to necessarily do this in your notes. If it had been x plus 2 quantity cubed, then you'd not only have this decomposition, but you'd also need another term with the denominator of x plus 2 to the third power. And if it had been x plus 2 to the fourth, you would need another term with a denominator of x plus 2 to the fourth power, and so on and so forth, right?
So it has.
Yeah. Now, don't get me wrong. It turns out the numerators will still be constant. So this would be, I'm going to change this, so don't write all this down. So all the numerators would be constant. It's possible one of these a, b, c, or d or more are 0. But you have to take it into account when you set up the decomposition. Okay, now that gets a little overly complicated. So let's go back to what we originally had. Okay, so you're going to have one factor of the repeated factor to the first power, the second power, and then depending on how high that power is, all the way up until you get to that power. Every power in between. Does that make sense? So now, after that, the method looks much the same. We're going to clear the fractions. What am I going to multiply through by? The LCD is always the guy on the left. So go ahead, Adam.
Can there be an X on the B? Because
No, I'm not going to try and prove it right now, but it turns out that whether you have repeated or non-repeated linear factors like in the last problem, or repeated linear factors, the numerator is always going to be constant. You can prove that. It's actually not that hard to prove, but I'm not going to try it right now. Multiply it out, clear the fractions. What do you get on the left side? Yeah, you always just end up with the numerator on the left side. On the right side? A times the quantity x plus 2. Only one factor of x plus 2 cancels. I'm sorry? Oh, it should have been a minus 7. I'm copying things down wrong today. Sorry. Okay. And then a times the quantity x plus 2 plus just b, right? Well, we could use a shortcut on this one, but doing it the long way is not that much longer. So what's the next step then? Multiply? Well, I'm sorry, go ahead.
is it quantity squared? A times x plus 2 quantity squared?
No, because think about it. This guy is going to land in the numerator here, here, and here. So this guy would cancel with one of the factors of x plus 2 that you have here and you end up with a times x plus 2. Make sense? Okay. Multiply it out. ax plus 2a plus b, right? Well, everything's already grouped and factored for you, so set corresponding coefficients equal. What does a have to equal in this one? Just -2. Well, that was a pretty easy equation to solve, wasn't it? So just a equals -2. Would you buy that? And then think of the 2a plus b together, because that's the constant coefficient. So what does 2a plus b have to equal? 2a plus b equals -7. And so this one actually turns out to be an easier problem than the last one. Because I suppose this is a system, but it's readily solvable, right? So what am I going to do to solve this? Hey, substitution is back. It's back in style. 2 times -2 plus b equals -7. -4 plus b is -7. So what does b equal? -3?
Negative. Oh, it's plus. Yep, you're right.
Okay. So, yeah, we add 4 to both sides, but you're adding 4 to -7, get -3. So we've got b, we've got a. Let's rewrite the decomposition. Remember what the decomposition was? It was a over x plus 2. So that means it's -2 over x plus 2 plus b over x plus 2 squared, which means it's plus -3 over x plus 2 quantity squared. Of course, if you wanted to bring the minus out in front and replace the plus with it, you could, but I'm just going to leave it like that. So in other words, -2x minus 7 divided by x plus 2 quantity squared decomposes to be -2 over x plus 2 plus -3 over x plus 2 quantity squared. So then what happens if you have an irreducible quadratic factor? Oh, it won't be that bad. But it will remind you of a factoring formula you might not have seen in a while. So we need to factor that denominator. Start out the same way we did in the others. Numerator stays the same, 3x squared plus 17x plus 14. Does anybody remember how to factor x cubed minus 8? That one's...
X minus, would be x minus 2.
It's got a short factor, a binomial factor, and a trinomial factor.
Is that x cubed?
That's x cubed minus 8. So
Minus
x minus 2 is the first one, and then
2.
you square the x squared.
Plus.
It'll be, when it's minus here, it's plus here. What's the next one? Do you double it or just take x times -2? Or x times 2, rather.
So it would be 2x.
It'd just be 2x, yeah.
Minus 2.
No,
No, 4.
plus 4. So here's the formula, guys. A cubed minus b cubed is equal to a minus b times the quantity a squared plus ab plus b squared. And then remember how it changes if it's the sum of two cubes. So if it's a cubed plus b cubed, then it's in front it's a plus b, but then the second factor where this first plus sign is, it becomes a minus. That's called the sum and difference of two cubes factoring formula, or the difference and sum formulas, the way I have it written. Does that look familiar to you? So I need to erase this, or at least move it. Shrink it down to nothing. How's the screen doing there? Or how's the projector doing there? Yeah.
You made it.
Really? That's all it takes? You better not go see the new Star Wars movie. Okay, let's set up the decomposition now. Okay. Well, okay, one factor here is linear, right? We know how to set that up, and it's non-repeated. So we'll just go a over x minus 2. And then the x squared plus 2x plus 4 is an irreducible quadratic factor. You cannot factor that thing over the real numbers. So that means that there's going to be one term. There's no repeated factors here. So there's just going to be one term for each factor. So you're going to have another term with that other factor from the denominator as the denominator in that other term in the decomposition. So x squared plus 2x plus 4. Okay, so then, Adam, you were talking about how it has to be a proper fraction. So this is when that comes into play. So it could still be a linear term up top, right? Well, you could have a linear term up top and still have a proper fraction on that term with the quadratic in the denominator. So how do you write a generic linear term or linear expression, let's say? So you'd have to have a bx plus c, mx plus b. It would work, but it would be weird. Okay? So whenever you have an irreducible quadratic on the bottom, you get a linear factor like bx plus c on top. That's the rule. So that's the setup, and that's the part that most students forget if they forget something. And then the whole problem's ruined if you forget that, right? I give as much partial credit as I can, but that's a biggie. If you, in other words, if you forget and you put like a constant on top, that's a big mistake. So don't do that. Okay, now the rest of the method looks much the same. Let's multiply through by the LCD, both sides, which is just this guy here. I don't have room on the left side, so I'll write it over here. X minus 2 times x squared plus 2x plus 4. Multiply both sides by that. And what are you left with? The left-hand side is really easy. It's always just the numerator, always. 3x squared plus 17x plus 14. Okay, what's going to be left after the cancellation's done on the right side? Okay, so a times x squared plus 2x plus 4 plus quantity bx plus c times just x minus 2. Okay? The shortcut won't work as well here. I mean, it will work to get a. You could plug in 2 for x, and that whole second term will cancel out. But it won't help you with b and c. So I'm just going to set up the system of equations. So before I do that, I have to multiply everything out, group like powers of x together, and factor out those like powers of x to identify the coefficients on the right side, and then set them equal to the coefficients on the left side. Does that make sense? So ultimately, we want to set corresponding coefficients equal, but we have to figure out what those coefficients are on the right side. So multiply out the right side for me. What do we get? I'll get you started. ax squared plus 2ax plus 4a. And then you guys do the tough one. Minus 2c. So that's the good old FOIL method, ain't it? So first gives you bx squared. The outer gives you minus 2bx. The inner gives you plus cx. And the last gives you minus 2c. Not that you need to use the FOIL method. Whenever you're multiplying polynomials, you just multiply everything in the first polynomial times everything in the second polynomial. It's really just distribution. Okay, let's group like terms together. I see an ax squared. Anything else with x squared? Okay, so let's group those guys together. So, and you know, you can cross out as you go. Not that you're canceling, just to keep track of things, to make sure you've taken it into account. It's a good idea. And then how about just the x terms? 2ax minus 2bx plus cx. So don't miss that. So cross them all out as you go, and then you'll know that you took care of it at the end. And then 4a minus 2c. You took care of those guys. Anything left uncrossed? Nope. So we didn't miss anything. Okay, factor out the x squareds. What's left? A plus b. Factor out the, okay, then a plus, and then factor out the x's from all three terms here. So x times what's left? 2a minus 2b plus c. And then plus 4a minus 2c. Now, plus 4a minus 2c is its own object. You could put parentheses around that. That's the constant, right? That quantity is the constant. Okay, remember what we have on the left side. I'll just put ditto marks until we get to the last line. On the left side, we have 3x squared plus 17x plus 14. And you set corresponding coefficients equal, which gives you your system. Can you tell me what that system is? Okay. Oh, I can't write that fast. A plus B equals 3. Equals 17, and 4a minus 2c equals 14. Okay. So this actually wouldn't be that hard to solve by hand. If I were doing it by hand, I wouldn't even use Gaussian elimination. I would just do the old method, you know, elimination or reduction, some books call it, by hand. This is a good opportunity to show you what the answer is and how to use the calculator to get it, though, because I'm going to allow you to do that on the homework to make the homework shorter. Okay? So you don't have to use Gaussian elimination or reduction. You can just use your calculator. On the calculator, exit out, get to the home screen. Okay, now go into matrix, which is, as you probably know already, second function x to the negative 1, right? X inverse. Over to edit. And you're going to plug in the full coefficient, back up. Whoop. The full augmented matrix, okay? The full augmented matrix. So, yeah, if you think about it, you're going to have a column for the A's, right? A column for the B's, a column for the C's, and a column for the constants, including that 3 right there. I just don't have it lined up. So that would be 3 equations, which means 3 rows by 4 columns. So 3 by 4. And then what would the first row be, including any 0 coefficient?
1 plus 1, or
1.
not 1 plus 1. 1, 1, 0.
And then don't forget the 3, yeah. And then 2.
2, negative 2. 1, 12.
17.
What?
Yeah.
Oh.
That guy.
wrote that down.
So for the video, that guy. And then and then 4. Oh, what's the next one? 0, because you don't see the B, right? Negative 2 and 14. Okay. And then exit out of there completely. And now go back into the matrix menu. You have to go second function quit to exit out completely. Go back into matrix. It seems like we're spinning our wheels, but that's how you have to do it. And over to math. So I haven't talked a whole lot about this yet, but we couldn't find the determinant of this matrix because it's not square. In order to find a determinant of a matrix, it has to be same number of rows as columns. But there it is. If you're wondering where it was at, there it is under the math menu. We're actually going to go up to where it says RREF, ref, and hit enter. Now call up the matrix. So just go back into the matrix menu. Once again, you're always going back into the matrix menu. But second function, x to the negative 1 if you have a TI-84. And then hit enter because it was matrix A. You can close parentheses, you don't need to. Hit enter. Check it out. So A equals 5, right? This 1 then is the reduced. So this is your reduced matrix after applying your Gaussian elimination method to reduce it not only to row echelon form, but row reduced echelon form. So this first one right here is the coefficient of the A, and the rest are 0. So A equals 5. B equals, this one is the coefficient of B. B equals negative 2. And this bottom one is the coefficient of Z. So, C. Which is 3. Okay? So 5, negative 2, 3, going downwards. And you're wondering right about now, why didn't he show us that a week ago, right? Okay, so what's the decomposition, you guys? Well, okay, let's take, this is the setup, right? So let's fill that in. Okay, so I'm just going to fill in A, B, and C in that. So what do I get? I get 5 over x minus 2 plus what? What do I get on top over here? Negative 2x plus 3 over x squared plus 2x plus 4. In other words, if you added these together by getting a common denominator, you would get what you started with, which was this guy in blue up here. Okay? Now, I only have 4 minutes, so I'm going to do a partial example for you, but I'm going to give you the important part in case it comes up in the homework. Stare at this for a second. We have x cubed minus x squared minus x minus 1 on top and x squared minus x in the bottom. You could factor the x out of the bottom, but it wouldn't cancel with anything. And there is something we need to do first. There's something about this problem that is different than the rest A, B, and C that we looked at. Yes? This is an improper fraction, right? The numerator, in the numerator, the degree of the numerator is greater than the degree of the denominator. So what you're going to want to do first is long division. Everybody's favorite, right? So this is what you have to do first, long division. So you're going to in the driveway, remember, you're going to put the junker car, right? X squared minus x. And inside the division garage, you're going to put the nice Mercedes. X cubed, or insert your favorite car there. X cubed minus x squared minus x minus 1. Oh, and by the way, if you want a placeholder for the constant, you could always, on the x squared minus x, you could always put a plus 0 if you want a placeholder for that constant, if that helps. Okay, so then ask yourself, what can I multiply x squared by to get x cubed? Just x. So the way I like to do it is I like to put that, so I'll do the rest in blue. I like to put that x above its like term in the garage, but you don't have to do it that way. You could slide it over if you wanted to. It wouldn't matter. And then I distribute the x times the divisor, x squared minus x plus 0. What does that give me? So that should give me x cubed minus x squared plus 0x, if you like, right? But that at least tells you where you should be lining up at, right? The 0x isn't going to do much, is it? Okay. Do you remember what to do next? Change the signs and add. Notice I'm not using synthetic division here because I'm not dividing by a linear factor. Okay, change the signs and add. What do you get? You better get 0 in front, right? And we also happen to get 0 here as well, right? And then what do we get here? Negative x. And then what do? Bring down the minus 1? Well, yeah, we can't do anything else though, right? Because this exponent on this one is less than this exponent here. So guess what, you guys? That's your remainder, isn't it? So you get x squared, so you get x minus what? Well, I'll make it I'll make it easy. I'll make it plus x plus negative x minus 1 over x squared minus x. In other words, this guy, this given fraction is equal to this guy. Would you buy that? Okay, now what don't I have time to do? I don't have time to do the partial fraction decomposition on this guy, but this is the guy you would perform the partial fraction decomposition on because it's a proper fraction. Perform the partial fraction decomposition, PFD. So in other words, you would factor that denominator and set up the decomposition, clear the fraction, do everything we did in the last few examples. Don't forget at the very end to add in that x, right? So this x in front is part of it, part of the decomposition, but you're not actually using the method of partial fraction decomposition on that x. You don't need to, just on the remainder term, or the term involving the remainder divided by the divisor, rather. Okay, and I think the full solution is in the notes posted online. Okay, that's it.